Bismillahirrahmanirrahim. In this lecture, we are going to speak about solving system of linear differential equations by elimination. As we know that system of equation means that we are trying to find common solution for two or more of the equations, and that solution must be satisfying the whole equation given in the system. When we speak about the solution of a system, the solution of a system of differential equation is a set of sufficient indifferentiable function x, y, z, three functions, the one that satisfy each equation in the system. So we are looking for a solution that satisfies each equation in the given system. Before explaining this idea, let's give some notation for the derivative first. Then we are going to apply elimination and try to find solution for a system. In this part of this lecture, we are going to use this notation dx of dt to be d of x. Using this notation, dx means the derivative of x with respect to t, and dy by dt, we write it as dy. Now, we have this example. I have dx dt equal to 2x minus y, and dy by dt equal to x, and we need to find the solution for the given system. It is a system of differential equations consists of two equations, two differential equations. So the idea is to find x of t as a function of x is a function of t that will satisfy the two equations, and also we need to find y as a function of t that satisfies each equation of the given system. Now, let's just rearrange the first equation. The first equation can be written as dx equal to 2x minus y, and the second equation is dy equal to x. This system can be written as, if we move 2x to the other side and y also to the left-hand side, we will have dx minus 2x plus y equal to 0, and minus x plus dy equal to 0. Or, if I take x as a common factor from the first two terms, I will have d minus 2 that is d minus 2 x plus y equal to 0, and minus x plus dy equal to 0. And to solve the system, I need to eliminate one of the variable, either x or y. Suppose that I need to eliminate y. To eliminate y. Mean that I'm going to sum between the coefficient, multiply the first equation by d and the second equation by the coefficient, let's say minus 1. To eliminate the variable y, we must have the same coefficient but opposite in signs. To multiply the first equation by the coefficient of the second equation of the y in the second equation, and multiply the first or second equation by the coefficient of the second equation. Multiply the first equation by the second coefficient of y, and the second equation by the first coefficient of y in the first equation. But we must have opposite sign, so that when we add, we will cancel or eliminate the variable y. So the first equation will be multiply d by d minus 1. It will be d times d minus 2x plus dy equal to 0. Second equation will be x minus dy equal to 0. Now if we add, we see that dy and minus dy will be cancelled. So I have x or d times d minus 2x plus x. So the equation is d times d minus x plus x equal to 0. Or I can take x as a common factor. It will be d multiplied by d minus 2 plus 1. X equal to 0. So this is d square minus 2d plus 1 equal to 0. I have d square minus 2d plus 1 equal to 0. By factoring, I will have d minus 1 square equal to 0. I will have d equal to 1. But it is repeated. I have to say multiplicity 2. Because for this one, now the solution x of t would be c1 e to power 1t plus c2, since we have repeated rows for the given auxiliary equation, it will be t e to power t. Now we have to find the y of t. Again, if we go back to the solution or to the system, now to find y. My system was d minus 2x plus y equal to 0 and minus x plus dy equal to 0. Now to find y, we are going to eliminate x. To eliminate x, multiply the first equation by 1 and second equation by d minus 2. Just multiply by the coefficient. This is the coefficient of the first equation, and this is minus 1, but we multiply by just 1 because it is already negative. Now we need to make it negative 1. So the first equation now will be d minus 2 x plus y equal to 0. And second equation will be minus d minus 2 x plus d minus 2 times dy equal to 0. If we add, this will be cancelled. Then we'll have d square minus 2d plus 1 y equal to 0. Or it is d minus 1 all to power 2. This is by factoring will give me 0, so that d equal to 1. So y of t will be c3 e to power t plus c4 t e to power t. So I have now two solutions or two functions. Y of t equal to c3 e to power 2 or to e to power t plus c4 t e to power t, and x of t, we found this before, it is c1 e to power t plus c2 t e to power t. Now for these two functions to satisfy the given equation, we must have some relation of these constants, c1, c2, c3, c4. So if we go back to one of the equation, let me say, if we use the second equation, I have minus x plus dy equal to 0. I need to find the relation. So using the second equation, that is minus x plus dy equal to 0. Minus x is given by minus c1 e to power t plus, or it is minus. I just substitute and replace x by given c1 e to power t, t plus c2 t e to power t. I will have this one. Now dy means the derivative. So we have to differentiate y. I will have c3 e to power t. Derivative for this one by product 1. will be plus C4 times e to power t plus t e to power t. Applying the product rule, equal to 0. Now if we combine the similar terms, I have minus C1, this is e to power t, C3, and C4 e to power t. This will give me minus C1 plus C3 plus C4 e to power t. And these will be together, combined together, plus minus C2 plus C4 t e to power t equal to 0. This will give me minus C1 plus C3 plus C4 equal to 0. So just try to find the, or compare between the coefficient on the left and coefficient on the right. This is equal to 0, which that will give me C1 equal to C3 plus C4. So C1 must be equal to C3 plus C4. For the second one, also minus C2 plus C4 equal to 0. This will give me C2 equal to C4. So if C1 equal to C3 plus C4 and C2 equal to C4, then we will have a solution that will satisfy the given equation in the system. So this is how to find a solution for system of differential equation by elimination. We need to eliminate one of the variable x to find y, and then eliminate y to find x. Then just plug it in the system to find the relation between the given constant or that found constant C1, C2, C3, C4. They are related somehow, so that we will have a solution that will satisfy for some, because it is not satisfying the system for any constant. We must have some restriction for these constants, C1, C2, C3, and C4.